Let's take a look at the homework in lesson 4.2.4. Something a little more challenging about this homework is that after questions 1 and 2, it forces you to remember how to write all of these compounds and then balance it. So I wanted to make a video for this because it's good to double check that you have the products written correctly before you start to try to balance. So I expect that in order to really get the best practice out of this video, that you're stopping and pausing and trying things on your own first. If you're just watching this to write in the answers, that's not really going to engage your brain and help you. So let's start by making an atom inventory for number 1. We've got phosphorus atoms and hydrogen atoms. There's 4 phosphorus on the left, 1 on the right, 2 hydrogens on the left, and 3 on the right. So right away I'm going to put a 4 in front of my phosphorus, which changes my hydrogens to 12. 4 times 3 is 12. That means on the left side I'm going to need a 6 in front of my H2 in order to make everything balance out. So we are done with number 1. Number 2, we've got titanium, chlorine, and magnesium. There's 1 titanium on each side, 4 chlorines on the left and 2 on the right, and 1 magnesium on each side. So I know I'm going to need a 2 in front of my MgCl2 to get my chlorines into balance, which throws my magnesiums out of balance, which means on the left side I'm going to have to add a 2 in front so that now everything balances. Number 3, we've got to write out fluorine, which is in Hofbrinkel, so it gets a 2. Solid aluminum oxide. Aluminum's got a +3 charge, oxygen's got a -2, so this becomes Al2O3, and it says it's a solid. And it says that it forms solid aluminum fluoride. Aluminum's got a +3 charge, fluorine a -1, so that becomes AlF3 plus oxygen gas. So this would be a good time to pause the video and try to balance this on your own. We've got fluorine, aluminum, and oxygen atoms. 2 fluorines on the left, 3 on the right. 2 aluminums on the left, 1 on the right, 3 oxygens on the left, and 2 on the right. This is a mess. It's a great idea to make odd numbers even, meaning let's get rid of that 3 for the fluorines and make it a 6, which also changed our aluminums. So we're not done here yet because it looks like on my left side I also have an odd number. So I'm going to throw a 2 in front of my Al2O3, which makes this 4, and now I have 6 oxygens. So now I need to go back and change this that I already changed to a 2 into a 4 because I need 4 aluminums. That also changes my fluorines to 12. 4 times 3 is 12. I'm going to throw a 3 in front of my oxygen so that I've got 6 oxygen. And now that I've got 12 fluorines on the right side, I need to change this to 12 fluorines on the right. So now my numbers match. 12 and 12, 4 and 4, 6 and 6. My coefficients are 6, 2, 4, 3. Let's take a look at number 4. Gaseous ammonia reacts with oxygen gas to form nitrogen dioxide gas and water vapor. Same thing as steam, so that's a gas. Alright, we've got nitrogens, hydrogens, oxygens. 1 nitrogen on each side, 3 hydrogens on the left, 2 on the right, 2 oxygens on the left, and 3 on the right. So what do I want to do? Let's start by making the hydrogens an even number. So I'm going to throw a 2 in front, which changes my hydrogens to 6 and my nitrogens to 2. That means I know I'm going to need a 2 in front of my nitrogen on this side. Now I've got 4 oxygens plus 1 more, 5 oxygens. But I'm not done because I have 6 hydrogens on the left, so I need a 3 in front to make that 6 hydrogens, which changes my oxygens again, 4, 5, 6, 7 oxygens. Everything's in balance except not my oxygens. So over on the left side, I can temporarily use a decimal here. 3.5 times 2 is 7, but I can't leave it this way because now I want to double all of my coefficients to get rid of that decimal so that it's 4, 7, 4, 6. For the next one, we've got solid sucrose reacting with oxygen gas to form our carbon dioxide gas and water. And I've got my carbons, hydrogens, and oxygens listed out. 12 carbons on the left, only 1 on the right. 22 hydrogens on the left, 2 on the right. I've got 13 oxygens on the left and 3 on the right. And remember, if there's only carbons, hydrogens, and oxygens, it's a great idea to balance them in that exact order. So I'm going to start by adding a 12 in front of my carbon, which changes my oxygens, 24, 25 oxygens. Next, I want to get my hydrogens in gear. So I'm going to throw an 11 in front of my H2 so that my hydrogens match. Now I've got 24 plus 11, that's 35 oxygens. And on the left side, I've already got 11 there. That means I need 24 more. So if I throw a 12 in front of my O2, I've got 35 oxygens on each side. So my ending coefficients are 1, 12, 12, 11. Lithium metal reacts with nitrogen gas to form lithium nitride. Lithium's got a +1, nitrogen a -3, so that becomes Li3N, and it says it's a solid, which makes sense, it's ionic. 1 lithium on the left, 3 on the right. 2 nitrogen on the left, 1 on the right. Let's make odd numbers even, so if I throw a 2 in front of my Li3, that makes it 6, and that helps out my nitrogens as well. But now I'm going to need a 6 in front of my lithium on the left. So 6, 6, 2, and 2. And our last one, we've got aluminum, which has a +3 charge, carbonate, a polyatomic ion with a -2 charge, so that becomes Al2CO3. Says it reacts with phosphoric acid, which is aqueous, and it produces aluminum phosphate. Charges cancel out there. It also produces carbon dioxide gas and water. So I've got a lot of atoms here, and unfortunately for me, the carbonate does not stay together. CO3 on the left, CO2 on the right. So I've got to treat the carbons and oxygens separately. 2 aluminums on the left, 1 on the right. 3 carbons on the left, 1 on the right. 9, 10, 11, 12, 13 oxygens, 9 here plus another 4. And then 4, 5, 6, 7 oxygens on the right. 3 hydrogens on the left, 2 on the right, and 1 phosphorus on each side. Okay, where to begin? Let's start with our aluminums. I'm going to throw a 2 in front of my PO4, AlPO4, which changes my P's to 2. Now I've got 8 oxygens, 2 times 4, plus another 2, plus that 1 on the end, that's 11 oxygens. Then I'm going to take a look at my carbons. So I've got 3 on the left, that means I need a 3 in front of my CO2. That changes my oxygens again. 8 plus 6 is 14, plus 1 more is 15. Let's make, since we have 2 phosphoruses on the right, let's throw a 2 in front of our H3PO4. So that's going to make my hydrogen 6, my phosphorus 2, my oxygen 9 plus another 8 is 17 oxygen. On the right side now, I'm going to throw a 3 in front of my H2O, making my H's 6, yay. And let's check out my oxygens now. I've got 8 plus 6 is 14, plus 3, 17. So now all my numbers are balanced, and my ending coefficients out front are 1, 2, 2, 3, 3.